Hi, in this speech I'm going to talk about Async Ruby. Async Ruby is an awesome addition to the Ruby language. It's been available for some time now, but relatively few people knew about it, and it has stayed off of Ruby mainstream. The goal of this talk is to show you, at a high level, what Async Ruby is about. Whether you're a beginner or an advanced Rubyist, I hope to show you something you didn't know about Ruby. We're going to go through a couple simple examples that show all the power of asynchronous programming. We'll also explain the core concepts of how it all works. I've been a Ruby programmer for 10 years now, and this is, in my opinion, by far the most exciting addition to the Ruby language during this time. My name is Bruno Sutic. I'm an Async Ruby early adopter, and I made a couple small contributions to it. You can find me on GitHub as Bruno-. I don't do social networks, but you can find my contact info on my webpage, brunosutic.com. Now, before jumping into Async Ruby, let's explore what does async really mean. What is asynchronous programming? I think it's commonly accepted thing that JavaScript brought async programming to the mainstream developer's consciousness. So I think it would be fitting to explain asynchronous programming with a simple JavaScript example. Also, I assume a lot of you have written at least a little JavaScript because it's so unavoidable these days. Now, let's look at this example. We're making a simple HTTP GET request to httpbin.org. We're registering a promise that runs when the request response is received. This function just prints the response status. On the last, fourth line of this example, we're printing some string. The output, shown below the code, is expected. This is a simple example of an async program, where we're usually making some I/O request and then something happens later in a callback when the request is done. One thing to note in the output here is the program first runs the code on the last line. It just prints the string. Later, when the request is done, it prints the response status. If you think about it, it's unusual for simple programs to run backwards, like line 1, line 4, then back to line 2. To us, developers and humans, programs that run top to bottom are easier to understand. The point I'm trying to make here is async programs are harder to follow and understand. Programs that run top to bottom, synchronous programs, are easier to reason about. In the case of JavaScript, as a program becomes more complex, they may end up in an infamous state called a callback hell or promise hell or even async await hell. So then, why would we want to make our programs asynchronous? Why not just stick to linear, top-to-bottom approach? The answer is simple: performance. To understand this, let's look at the following example with some JavaScript pseudocode. Here, we're making 3 HTTP GET requests, and each one takes 2 seconds to run. How long will this whole program run? Surprise, surprise! The program will run for 2 seconds total. In this example, we are firing 3 HTTP requests at practically the same time. The trick is that waiting for responses happens in parallel. Asynchronous programming enables this parallel waiting, and that's how we achieve these big performance gains. If we look at the equivalent code in Ruby, we'll see that the same example takes 3 times longer to run. In this case, 3 times 2 seconds equals the predictable 6 seconds. Reason for this is there's no parallel waiting on the responses. Ruby is synchronous. So, how do you make 3 or 5 or 100 requests in Ruby more performant? You use threads. In this example, we see how to speed up our program with 3 requests in Ruby. The whole program finishes in 2 seconds. This works. And now you may be wondering, Ruby isn't asynchronous by design, but it has threads. Are we good then? If you've done any real-world programs with raw Ruby threads, You know the answer to that question. Threads in Ruby are hard. Specifically, there are two problems with them. The first is language level race conditions. These are particularly nasty and hard to debug. This type of problem can occur with even the simplest thread programs. The second problem with threads is maximum number of threads. This matters when you want to make a large number of parallel requests. I just tried maxing out the number of threads on my machine, which is a mid-range MacBook. The maximum number of threads I could spawn was 2,000. That may seem like a lot, but if you have, say, 1 million HTTP requests to make, that number of threads is not sufficient. Let's talk about Async Ruby now. Async Ruby is a new type of concurrency in Ruby. If you ever think, I want to do multiple things at the same time in Ruby, async may be a good fit. For example, you want to serve more requests per second with the same hardware. You want to make more requests with your API client at the same time. You want to handle more WebSocket connections concurrently. Ruby has a couple options when you want to make multiple things at the same time. First is, you can do more work with multiple Ruby processes. Second approach is reactors, a new Ruby 3.0 feature which it seems is not production ready yet. Third approach, which we already mentioned them, are threads. And lastly, we now have async. So, what is Async Ruby? How do you run it? Async is just a gem and you install it with gem install async. That's it. It's a very nice gem because Matz invited it to Ruby standard library. The invite has not yet been accepted. Gem creator is Samuel Williams, a Ruby core committer. So you can kind of feel Ruby core team, including Matz himself, are backing this gem. Async Ruby is also an ecosystem of gems. There's Async HTTP, a really powerful HTTP client. There's Async Await gem, which is just a syntax sugar. Falcon is a highly scalable async HTTP server built around async core. We have async Redis, async WebSockets, and others. This talk will focus the most on the core async gem and the accompanying Ruby language integration. Let's do an async Ruby example that is equivalent to JavaScript example we had before. In this example, we're using async HTTP gem. The only thing you have to know about it is it's an HTTP client. You call get on it and it makes the request. The actual code starts with a capitalized async, a kernel method with a block. All the asynchronous code in a Ruby program is always wrapped in this async block. Async Ruby has a concept of tasks. We spin multiple tasks when we want to make things run concurrently. In this example, we're running 3 requests at the same time. And just like in the previous JavaScript example, all 3 requests are started at virtually the same time. The big win is that waiting on the responses happens in parallel. The total running time of this program is slightly more than 2 seconds. It's not exactly 2 seconds because of the network latency. This basic example shows the general structure of async Ruby programs. You start with an async block that is passed a main task. That main task is usually used to spawn more async subtasks. These subtasks run concurrently to each other and to the main task. Just to make it explicitly clear, async tasks can be nested indefinitely. So a task block is passed a subtask, which can again create a subtask, etc. Another thing to clear out is it's all just Ruby. Async does not contain any special DSL, nor does it do gimmicks like monkey patching. The previous example performs only HTTP requests within tasks, but you can run any Ruby code anywhere, main task or subtasks. It's just regular Ruby code with method calls and blocks. Okay, Hopefully you've had a positive first impression of Async Ruby. Once you get a little used to how things work, you see it's really neat. And the performance benefits are awesome. Let's now see another code example. If you're not impressed yet, this may just blow your mind. You may have not liked we're using a new HTTP client in the first example. The truth is, you can use Ruby's URI.open to achieve the same result. Here, we see that 2 requests triggered with URI.open are completed in about 2 seconds. Same result as before. But URI.open may also not be your favorite tool. The brilliant thing about Async Ruby is that any HTTP client is supported. Let's use HTTP party and see how that works. Okay, the program ran in about 2 seconds, which means all requests ran concurrently. So far, we've only seen examples making HTTP requests. But what about other network requests? Let's try Redis, which has its own protocol built on top of TCP. This Redis command runs for 2 seconds before returning. We run the program and it completes in about 2 seconds. So, wow, we can also make Redis commands asynchronous. In fact, any I/O operation can be made asynchronous. All existing synchronous code is fully compatible with async. You don't have to use async-only gems like async HTTP or async Redis. You can just continue using the libraries you're already familiar with. Let's add another example to the mix. I'll use netSSH to execute an SSH command on the remote server. This SSH command runs sleep on the target server and it runs in about 2 seconds total. Okay, there you have it. We added SSH to the mix and it works seamlessly with other network requests. You may be wondering, what about databases? We connect to databases over the network. I'll use SQL, the gem, to check if asynchronous database operations are supported. The query you're looking at takes exactly 2 seconds to run. And yes, that is supported as well. Cool, right? Let's see another example. What do you expect this sleep will do? Will it increase the total program duration by 2 seconds? The whole program runs in about 2 seconds, which indicates this sleep ran concurrently with the other tasks. Nice! So not only can we run network I/O asynchronously, we can also run other blocking operations async. What other often used blocking operations do we run in Ruby? How about we try spawning new child processes? I'm using a sleep system command in this example. Don't get confused, this is actually running an external system command. It could be any other executable. I chose sleep so I can easily control the duration. And there you have it. System commands can run async as well. We covered a lot in this last example, and hopefully these features look exciting to you. You saw something new, something really innovative in Ruby. But that's not all. Let me show you how easily does Async Ruby scale. I will run every task in an async block 10 times. Quick note about netSSH. I had to remove that one because I couldn't figure out the correct SSH configuration for this example. What do you think? How long will this program run? Two seconds. Yes, we're running 60 tasks, each lasts 2 seconds, and total program runtime is slightly more than 2.5 seconds. How about cranking things up? How about we repeat this 100 times? Let's see what happens. We're now running 600 concurrent operations. The total program runtime increased by a second because of the overhead of establishing so many connections. Still, I find this pretty impressive. So, there you have it, easy scaling with async. You can crank the numbers up, but in my case, Redis server and Postgres database started complaining, so I left it at that. And you can argue we could do the same thing with threads, creating 600 threads. I think that's really pushing the limits with threads. My hunch is that thread scheduling overhead would be just too high. When using threads, it's more common to limit the number of threads to say 50 or 100. On the other hand, 600 concurrent async tasks is a common thing to do. The upper limit on the number of async tasks per process is single-digit millions. Some users have successfully done that. This limit, of course, depends on the system and what you're trying to do. For example, if you're making or receiving network requests, you'll probably run out of ports at 50,000 concurrent tasks, unless you play with your networking. In any case, I hope that you get the idea that Async Ruby is a very, very powerful tool. To me, the biggest magic is running 3 HTTP requests with URI.open. With vanilla Ruby, that takes 6 seconds. And then, by using the same method within async block, the program runs for 2 seconds. Same with other examples, Sleep, Redis, etc. They all normally run in a blocking way, but then inside an async block, they work asynchronously. It's a great example of keeping Ruby code fully backwards compatible. But how does that work? There's a lot to learn about Async Ruby, but I think there are 3 main concepts to understand: Event Reactor, Fibers, and Fiber Scheduler. Each of these 3 topics is very broad, so I'll just provide a summary. Let's start with the Event Reactor. Event Reactor is sometimes called other names, Event System or Event Loop. Every async implementation in every language, say JavaScript, always has some kind of event reactor behind it. Async Ruby is no exception. Current version of Async Gem uses Neo4r Gem as an event reactor backend. Neo4r then uses libev to wrap systems native APIs, EPOL on Linux, KQ on Mac, etc. What does the event reactor do? It effectively waits for I/O events. When an event happens, it performs an action we programmed it to do. On a very high level, we make an HTTP request and then we wait. Event Reactor can notify us when the response for that request is ready and can be read from the underlying socket. These notifications are very efficient with resource usage and allow high scalability. For example, if you hear a server can handle 10,000 connections at the same time, or a crawler can make a large amount of concurrent requests, Event Reactor is probably the technology behind that. You saw async has tasks. Tasks are just wrappers around fibers. Event Reactor drives the execution of these fibers. For example, when a response in task 1 is ready, Event Reactor resumes task or fiber number 1. Later on, when a response in task 2 is ready, it resumes task or fiber number 2. You get the idea. Due to the decision to register fibers with event reactors, we get a really nice property that code within a single task behaves completely synchronously. This means you can read it top to bottom. This is huge. It means our async programs are easy to write and understand. The code behaves asynchronously only if you use task.async. There's no way you can get callback hell with Async Ruby. The last piece of the puzzle and the last big concept is Fiber Scheduler. Fiber Scheduler was listed as one of the big Ruby 3.0 features. It provides hooks for blocking functions inside Ruby. Examples of those blocking features are waiting for an I/O read or write, or waiting on a sleep function to finish. In an essence, Fiber Scheduler turns blocking behavior into non-blocking behavior inside an async context. Let's take sleep method for example. If you're running sleep2 in an async block, instead of blocking the whole program for 2 seconds, the Fiber Scheduler will run that sleep in a non-blocking fashion. It will use Event Reactor's timing features to effectively sleep in one task while allowing other tasks to run during that time. So, that is the big benefit of Fiber Scheduler. Along with Fibers and Event Reactor, it makes Async Ruby seem like magic. Okay, now that we have a high-level idea how things work, it's time for the big question. Does it work with Ruby on Rails? The answer is currently no. The reason is Active Record needs more work to support Async Gem. Another big question that you may have is Async Ruby production ready? The answer to that question is yes. Async Ruby is production ready and a number of people are running it in production. Everyone using it says nothing but praises about async. Recently, I've talked to Trevor Turk from HelloWeather.com. They've replaced Puma and Typhus Hydra with Falcon and Async HTTP. They immediately cut their server cost to 1/3, and their overall system is now more stable. If you're excited about what you saw in this speech, you're probably asking, how do I get started? I think the single best starting point to learn Async Ruby is Async GitHub repo. From there, you'll find a link to project documentation. I've already mentioned Samuel Williams, but I think it doesn't hurt to say this again. This guy is the sole creator of Async Ruby, Async ecosystem, and a Ruby core committer that implemented Fiber Scheduler feature. Huge thanks to Samuel. He's making an awesome contribution to all of us Ruby developers. I hope you liked what you saw in this speech. Async is an exciting new addition to Ruby. It's a whole new type of concurrency added to the language. As you saw, it's super powerful and very scalable. This changes what's possible with Ruby. It changed the way I think about designing programs and apps. One of the best things is it does not obsolete any of the existing code. Just like Ruby itself, Async Gem is beautifully designed and a joy to use. Happy hacking with Async Ruby.